Hacker Talk, the webcast series brought to you by BreachLock, a global leader in offensive security solutions, offering continuous attack surface discovery, penetration testing, and red teaming. Hi, I'm Chesbrough, and I will be your host and moderator today. Today's webcast is all about pen testing in AWS environments. Today's penetration testing plays a critical role in securing AWS environments. As cloud adoption continues to expand, so does the complexity of securing these dynamic infrastructures. AWS environments come with their own unique security challenges, from managing identity access management roles to ensuring configuration compliance across various services. In this webcast, we will explore how penetration testing provides proactive insights into vulnerabilities specific to AWS, helping organizations protect their cloud assets from evolving threats. Join us as we discuss practical approaches, AWS-native tools, and best practices for conducting effective penetration tests that align with AWS's security and compliance standards. Now, I am excited to introduce our guest speaker, Ankit Giri. Ankit recently joined BreachLock as the Director of Pen Testing Solutions. He is a penetration tester by profession and a part-time Hall of Fame bug bounty hunter with over 10 years of experience. Ankit joined us from JPMorgan Chase, where he served as a technical lead in DevSecOps, performing hundreds of security design reviews and assessments, deploying proactive security for web applications and data stores. His prior experience spans an array of industries, including security engineer and analyst positions for leading information security companies, where he provided expertise for the planning and execution of security policies and procedures. His experience spans web applications and web services security, mobile applications, cloud, and IoT security. He is a current member of the Cloud Security Alliance in India, an avid public speaker at major conferences, as well as a leading author on web applications and network security. Welcome, Ankit, and we are pleased to have you as our guest speaker today.
Hey, thanks, Anne.
Before we start the webcast, I'd like to go over just a few logistics. If you have any questions during the discussion, please feel free to put them in the chat, and we will try to answer them. We will also take questions from our audience at the end of this presentation. Lastly, today's webcast is being recorded live and will be made available on demand at breachlock.com after this live airing. With that introduction, I'd like to turn it over to our guest speaker and expert, Ankit Giri. Thank you, Ankit.
It's a pleasure to be talking about pen testing AWS environments today. I'll briefly talk about how does the whole agenda looks like for today's session. So since we know that the adoption rate for cloud-based deployment have increased multifold, and referring to the same thing wherein the security assessment for cloud environment even becomes more critical in today's time. Having said that, how can we approach or how can we pen test our cloud assets in environments like, let's say, AWS? We have kind of segmented this into pieces wherein we would start with something like a reconnaissance and move towards discovery. And once we are able to discover and assess the attack surface, moving more towards vulnerability analysis, and then further to exploitation to look into each and specific areas of service categorization that we need to target. And not only that, we would also jump upon to see and understand how does the security misconfigurations look like, what kind of analysis we can perform in each service type, and also what should exactly be a pen tester looking for. And at the end of it, how does the whole reporting look like when we have to do these kind of specific assessments. That being said, we would first focus on the initial part wherein we have to kind of do a reconnaissance to understand what all AWS services are being consumed in the AWS account, organization, or business unit we are going to assess. That being said, not only all the AWS services that we are looking at, we are also trying to detect all the publicly exposed endpoints or infrastructure components that we can have. Plus the additional areas like what are the different hosted applications and what are their deployed components that are already in AWS. So these could be load balancers, these could be virtual appliances, these could be public IPs, and a whole era of those kind of components and their application set. That being said, we would also try and recollect or make a list of all the internal components. That essentially means that understanding how the AWS internal network level components work, like, which essentially means that are we looking at a elastic compute cloud EC2 instance, and how does that kind of connect to VPC, and what kind of subnets are configured, what kind of port and protocols are allowed. That essentially means that we are trying to also look into what kind of internal communication happen between service A to service B. That being said, all of this, once we kind of start to collect it together, we would also have a lot of aspiration into how we can achieve this. For that, there are different ways, and when we say different ways, there can be different ways to enumerate the OU or the account or the services that we want to target and find vulnerabilities upon. That being said, there are three major areas wherein how I kind of see them categorized. The very first being open source is a set of open source tools. That essentially means that we can always leverage these open source tools like Cloud Security Suite, Prowler, or AWS inventory to generate something like a reconnaissance or a fingerprinting of the whole account, or the account in picture or scope. That being said, we are not only limited to consuming something like an open source tool, but we can always leverage a lot of internal AWS services itself. So services like AWS config or workload discovery is something that can be used for internal analysis to understand what all services are consumed and leveraged inside an AWS account. That being said, we can always look and see if the organization that we are assessing or the organization that we are looking after from an penetration testing perspective, do they use something like a CSPM solution already? That could be anything, be it from Wiz to Divi Cloud, or any other CSPM solution, or a cloud security posture management solution, because they already have a bunch of all the inventory analysis done. They already contain a detailed view into what all services are being used, and for each service what are the resources that are already available. So maybe these are three ways of doing it. We can always combine two approaches. Majorly what I have seen or used in my experience is something like a combination of open source tools plus an internal AWS services coming together, because that kind of gives a very comprehensive view from an attacker perspective, coming from an external adversary side, or an internal attacker perspective, wherein the attacker could be somebody right in the organization itself with an elevated privilege. So that being said, the discovery, we talked about what, like why we should be doing the discovery, but then we also talked about how. And if we have to kind of drill it down further into steps, the major starting point is kind of listing down the services in use, because there might be more than 10-20 services in use, but we have to always kind of create a attack mind map wherein we are kind of looking at each service and also trying to boil down to the fact the most used services inside an account, so that we can kind of target them in a way that we are uh, focusing and finding the right set of vulnerabilities and also prioritizing the business criticality. That being said, with a list of services, what we are trying to achieve here is the mind map that we talked about. Then we talked about the vulnerable areas, and also not restricted to this, but also service configurations. So when we have all of this in mind and we have them ready, then we can move to the next step, which is more like service interactions, wherein we would be looking at, let's say, we have kind of collected all the information for how we are kind of consuming elastic compute cloud or EC2 or virtual instances, and we have their mind map ready in terms of what is the consumption looks like, or the vulnerable areas or the service configurations. But we are also looking at the service interaction. So does EC2 interact with something like VPC? Does EC2 interact with something like Lambda or a service serverless function and things like that? This is where we also have to kind of tap in the inter-service connectivity and then move on to something like focusing on the areas wherein we want to target. So not only we would look to target the service that is being in use, but we will also target the services that make the whole functionality possible for, let's say, deploying an application. So things like that would come into picture when we start to move to other stages. But yes, from a discovery perspective, from in starting point to listing the services to at the end creating like a mind map with all this information as a testing focus area would be a very comprehensive way to target AWS account from a pen testing perspective. That being said, we talked about certain open source, also internal AWS services, and some third party tools as well. But then we can always look and get a different kind of assets or asset discovery through these. And we can always generate a set of outputs that we will leverage later. Uh, when I say later, this is where right exactly wherein the next step kind of comes into picture, which is more like vulnerability analysis. So we have kind of now understood that this is how my AWS account is spread out. This is what all services are in use. These are the configurations inside each service. Now it is more time to get back to the actual thing, which is more like vulnerability analysis or jumping right into testing things for vulnerability. Once I say that jumping into testing these services or configuration for vulnerabilities, it essentially means that for each of the service type, there would be use cases that we have to target. And for each kind of services that we see, the use cases will differ. That being said, what I'm trying to say here is, if we are going to target something like compute, the use cases would be more centered around the ingress, egress points, then also the computation, the protocols, ports allowed. But then when we will talk about something like storage, the whole gamut of test cases would change, because then we would be looking at encryption. Is there encryption at rest enabled? Are we making any versioning enabled for buckets and things like that? How is the public access being managed, and so on and so forth. So this is very specific to each service. That is why the earlier stage wherein we discovered each service with the configuration would come in handy. So we will now start to jot down on identifying the starting points and then move towards something like a service specific testing. For this reference, maybe we will pick one category and then leverage that further to understand the configuration testing. So when I say configuration testing, it essentially means that if we see how EC2 instances are configured in an account, we would get into understanding what is the whole launch configuration looks like. Have we kind of allowed all the protocols to be enabled and all kind of inbound and outbound access to be enabled, or is it very filtered and it is only restricted to certain set of IPs that can access these EC2 instances that we are launching? That being said, it essentially correlates to, or analogically very similar to something like a network pen test, wherein we are going back to analyzing if there are any insecure ports being open. So are we leveraging things like opening port 22 for SSH on these EC2 instances, or we have it very filtered and blocked and only 80 and 443 allowed from a certain set of IPs? Again, these set of source IPs have to be validated against a set of what is the source look like. Have we kind of set a default setting with 0.0.0.0 or to the public web, or we are going very restricted in this manner wherein we are only whitelisting either the people equipped to access these instances or the organization's VPN IP or the IPs that they might possess. So that being said, since we talked a bit about compute, but when we actually enter an AWS account, the most essential or the most primarily service that we encounter is something like an identity and access management. That being said, IAM is what it is abbreviated in AWS. So it caters to multiple use cases, but everything that has to happen inside AWS would go through IAM route, because the provisioning for privileges or the accesses would happen right from this service. So that being said, I would try and segment into 5 pieces and then counter each one of them in a way that we are finding new vulnerabilities or finding security misconfigurations while we are reviewing an AWS account. That being said, the very first step for this would be something like checking if the AWS accounts, how are they being managed? Are they being managed in a way that there is a root account, or are we checking and making sure that we allow two-factor authentication to be enabled and people have only access if they have enabled these kind of configuration? Then the second step is, are we making sure that all the accounts are segregated in a manner that they provide accesses to high, low, and medium privilege account? When I say high privilege account, these are sensitive accounts which hold more privilege or access to the account and they can do more things. But are they having that second layer of security like MFA? Or have we kind of disabled the root account or kept it very secure? So those kind of security test cases have to come into picture for this. The other step would be kind of checking the user rights management to see, are we making use of policies for each user type, or we are already making group for each kind of user set. So be it stakeholders, DevOps, or security testing team, do we have segregated groups for these? And also for each group, are we applying the policies over groups and keeping them as least privilege, or going by default deny all kind of a policy, and not from a default perspective wherein we are provisioning users and giving them administrator access or higher privileges access by default, because that is something that have to be flagged out at this stage right itself. uh, Not just limited to users groups and the policies applied, but we also have to kind of look at environment segregation, wherein we have to make sure that the account that we are foreseeing has different environment segregated based on production or staging, QA, or dev, because the restriction or the access control would vary depending upon the kind of data that it possesses. So more of like a production infrastructure might deal with a lot of customer data and it would require more stringent controls, while something like a dev environment is more in terms of something that needs a lot of testing and lot of people internally needing access to the data and to be able to change things. So there would be a proper environment segregation and tagging to support on that. And then last but not the least, what we should be looking at is something like a role based access. So essentially, while it is very easy to provision users and access key and secret key for each account, but then in terms of service to service interaction, maybe like an EC2 instance kind of triggering a Lambda event, in those cases it's not an ideal practice to kind of supply the access key and secret key to the EC2 instance, but rather they should be provisioned with a role based access control. Eventually, what is the good part with use of a role based access is that every 15 minutes or so AWS itself would rotate the credential for these kind of roles. So that essentially means that there is a lesser chance of leakage of credential, and also the privilege can be associated to each role on the use case basis. So we will also talk about this with other services coming into picture, but this is how a complete gamut of the identity and access management and the policies around it are reviewed from an access management perspective. But this is a big chunk, considering that this whole IAM kind of helps us leverage the cloud computing functionality from each service or each computation perspective. That being said, I would move to more towards the individual services which more of like deal with user data or data that is critical, that either needs to be shared or it is kind of hosted for static use cases like hosting a static website and things like that. And this is where I think the exploitation part comes into picture. So we will talk about different things available or as a storage category inside AWS. So there are like gateways, elastic block storage, EBS, and a lot of other services. But then we can focus a bit on the S3, which is the simple storage service, which essentially means that it kind of comes in from a format that it provides us a lot of capabilities. So we can always go ahead and host files, folders, and static website. But that being said, that also kind of becomes a very easy target for a lot of adversary or attackers to come into play and target this service to be able to extract sensitive files or get a knack of what is in the backend of an computing deployment, like log files or backup file and things like that. And also a lot of times wherein there are websites which kind of store a lot of their consumer data right on S3. So this is where it starts to become like a treasure trove for data, and essentially a very essential service to be targeted from an pen testing perspective. So there are different ways to do it, and I'll talk about certain configurations, but not to miss out on something like there are always dedicated tools available in the open source world. So something like an S3 scanner, which I generally have used a lot for attacking these S3 buckets. But we can always make use of something like AWS CLI and Prowler, which are like cloud security offensive tools, right? Which not only target S3 bucket but a lot of other services. But for now, what this tool in picture that we are talking about, S3 scanner, does is we can just simply pass on a certain set of bucket names or a list of bucket names, and it will traverse it through to identify if these buckets exist or not. It will also list down all the policy or privilege associated to this bucket. Is it public, is it private? And then it will also list down what are different kind of auth users and unauthorized users are there. What essentially as a pen tester I would be looking at it from this data is all the buckets that have a public access enabled. For me, that would be the first target area. I would try and uh, target it in a way that I will try and enumerate and fuzz all the files or folders right on that S3 bucket. But that being said, that is the top level of attack that we can try and target. Not only limited to that, we can always go back and see how the S3 buckets are configured. So when I say configured, we can always make use of something like an AWS CLI, which essentially means that we can check what are the policies assigned on this bucket. So if we are kind of hitting roadblocks, we are not able to exploit or find any public bucket, or not able to find any misconfiguration right in the bucket policy or things like that, then at least are we able to probe it in a way that we are able to find the policies applied on these buckets? Are they accessible to other accounts or limited accounts, or uh, can we at least do a list access control on this bucket to identify how they are kind of making use of restricting access to this bucket, and maybe is there a way can we bypass it? So this is where our attack chain would come into picture. So there can be a case wherein bucket is restricted or controlled, or in a very controlled environment, and it does not allow access from any other AWS account. But if I have a read-only account, I can still go back and request an access to this S3 bucket and extract a lot of data. That being said, it is an essential thing to check. There is always a set of get, put, list kind of an permission on each bucket, which essentially means that with get you can fetch some data out of the bucket. With put, you can upload some data onto the bucket. So these are the cases wherein we should be trying and seeing if we can not only limit to what all test cases we talked about, but can we also push any data from our side to the bucket itself? That can also be cases wherein we are trying to achieve something like a malicious file transfer or transmission, uploading these kind of files, or we are trying to replace a critical information right for a application to work. Can we replace some static files like css files or javascript files and things like that? Can we kind of look into those scenarios wherein we are kind of replacing the assets that an organization consumes? So with that, you can always check for a tool like Prowler, which essentially is a complete comprehensive tool which scans through the complete configuration for each service. But then you can also run this tool with dedicated command for storage and supply it to just target the service in mind, which is more like S3. So that being said, there can be multiple use cases that can stem out of this, but then we can always look into how exactly we can kind of segregate them through in other services. So we have talked about IAM, we have talked about compute, we have already talked about something like the storage, which is more like S3 or S3 targeted. But then in general, we can also look at security misconfiguration review, which is the largest chunk of the testing that we perform on AWS account environment, which essentially means that, let's say I have an an EC2 instance and I'm kind of looking at its network configuration, what all should I be looking at? So a couple of things could be an open port, what all open ports are there, and inbound and outbound traffic that is allowed. Not only that, essentially what we are trying to boil down to is to see that there should be a minimal outbound connection. So this not only applies to EC2 but any kind of compute service being used. So it could be ECS containers or deployment models or Lambda, wherein we should be looking at the traffic management to see if there is a lot of outbound that is happening. So that essentially means that we are trying to do a compute configuration to analyze the access privileges right set, or if they are misconfigured in a way therein there is that is going to hamper us in future, wherein the privileges are not defined correctly for these compute resources, and there can be a lot of outbound data that can happen. When I say outbound data, it essentially means that considering scenarios like, let's say there is an EC2 instance and let's say it gets compromised, and what if it can make a lot of call right from the word, wherein it can be triggered to do Bitcoin mining, can it be triggered to reach out to multiple servers to execute different kind of attacks. That being said, we can kind of talk about other scenarios as well, but there are multiple ways of looking at it, but compute configuration is top priority that should be assessed. Also something like exception handling, which essentially means that if we are trying to target or assess, let's say the user data for an EC2 instance, or we are trying to open a URL with the S3 bucket endpoint, are we kind of getting some exception or error, and is it kind of giving us more data, is it kind of leaking some internal IPs or things like that, is the exception management being done correctly? If not, it can still give us some insight into the intricalities or the internal functionalities, and maybe that can lead us to a chaining of attack, and we can boil it down further to target the assets or the architecture in a much better way. Yes, this is where all of this translates into, and I would like to give an example wherein the EC2 kind of comes in with something like an IMDS, and by default, or in past, it used to come with something like an IMDS V1. Now, this IMDS V1 is essentially a way for the EC2 instance metadata to be publicly accessible or to be consumed by other services. That being said, this allowed a lot of attackers to kind of probe internal instances or IPs, because this is an entry point for an SSRF attack. Since it allows interacting with the metadata of the EC2 instance, we should always check and see if the IMDS v1 is enabled on an instance or not. Ideally, or from a security proactive perspective, if it is a right move to IMDS v2, it is fine, but any EC2 instance still leveraging a protocol like IMDS v1 would be vulnerable to something like an SSRF attack. We have already talked about open port and protocol and how it can be a security vulnerability that should be reported or detected. But that being said, once we are talking about protocols, we should also be looking at finding interesting protocols like SSH, and especially with the use of username and password combination, because the ideal way of using authentication on remote servers should be either a Kerberos or a token based or a key based mechanism. And we already talked about inbound and outbound connection. Mostly all of this kind of boils down to a fact that in a cloud environment, attack chains is something that would come into picture a lot, because a loosely configured IAM user role can take us to something like an EC2 or an S3 bucket, which is publicly exposed and it has certain files, can take us chain it back to something like escalating our privileges. Maybe it can contain something like a database backup file or a backup file with internal credentials, and maybe we can leverage those credentials to even escalate our privileges to something like an admin kind of a role. And we can do much more. We can see the complete account, we can modify a lot of things and things like that. So all of these security misconfiguration, they kind of have a next step to them, and they have a correlation wherein they can always be clubbed together, and we can always make use of one vulnerability detected in a certain service to its interaction with the other service in mind. So that being said, now since we have talked about discovery, vulnerability detection or identification, exploration, exploitation, and how we would do the security misconfiguration or the security configuration review, that would end with something like compiling all of this and putting it in terms of something like a delivery. When I say in terms of delivery, it essentially means that we have to kind of boil down all the findings and observation and compile it in a report with artifacts. That essentially means that we have to kind of put in all the identified findings, document all the key observations. So there might be cases wherein we tried for certain things, we tried for certain accesses, but we could not gain them, but at least we had some observation. Let's say we were able to list down the ACLs or the access control policy on the S3 buckets identified. They should add on as an artifact. But then, having said that, a report should be there which kind of contains all the description of vulnerability, proof of concept, and also it should outline the remediation. So not only that we are saying that for in, let's say example, an EC2 instance was using IMDS v1, what is the corrective action for the same? With all of that coming together, there should be a compiled report and there would be supporting materials to support it. So let's say we ran something like an S3 scanner and there was an observation report that came through. We ran something like a prowler, and again it kind of has the capability to generate a lot of HTML based reports. We can compile all of that together apart from the report that talks about all the technical details, but also as a supporting evidence to be included as an artifacts. So that being said, this final delivery that we are talking about essentially should be a report with all the proof of concept artifacts from individual tools. And this report should not only limit to the findings or vulnerabilities, but also a lot towards the observation notes. Now, why I say observation notes is because not only the areas wherein you see that there is a security misconfiguration are meaningful, but there should also be areas wherein the security posture looks good and there is already some good set of configuration in picture. But the observation notes would help us identify the good and the bad areas and prioritize the areas wherein or the services that require more effort to be able to kind of reach a better or a secure posture. So having said that, all of this report at a, or coming from a end user's perspective would help the organization understand the vulnerabilities better, also understand the attack scenarios or exploit path possible for each vulnerability detected. Uh, Not to miss out on something like a assessing of impact and likelihood, so that plays a pivotal role in vulnerability prioritization, and also a proof of concept to always visualize and see how exactly a vulnerability was found out, and then at the last step something like a compiled final report. So that being said, we talked about basic services or the services that are generally in use, but then nowadays the plethora of services have expanded a lot. So we see a lot of services related to either AI or infrastructure as code, or a lot of services that are still in beta stage, and a lot of organizations are still using it just to identify how exactly can they leverage it in future. That being said, it kind of acts as a attack surface analysis from an enhanced perspective or an extended perspective, and it kind of from my eyes opens up something like a blind spot in the complete exposure management. Why I kind of give it an analogy of a blind spot is because there are times wherein an organization might try a service. They would go back to trying something at their end. Let's say ECS, they are trying ECS to replace it with something like a container service on their on-prem, but then they find that this is not a good replacement and they are good with the existing solution. Can they still kind of in a secure manner stop using this service? So there are times wherein there are lambda functions that are running, but they are they are running in the background, but they are not actively being used. There similarly for user access controls, there are IAM users that are left orphaned, they are not being used. Those kind of blind spots is what we are talking about, and this is where new services kind of create vulnerabilities, because since the information is very less available, we are yet not sure how to kind of securely use them or configure them, because currently it is in a very nascent state. That being said, there is also a lack of awareness wherein while we are always trying to make the best of the technology out there, but at the same time, how exactly can we leverage it to use it at the best way possible, and in a very secure way possible. An example could be using something like a service which is essentially meant to run serverless function or automate functions, but then we haven't found a way to what is the exact set of secure configuration for the same. Same applies to something like an IAC, because not only we are looking at all the configuration and the infrastructure already spent up, but IAC is a very critical piece, because any of the code that we write to automate or build a infrastructure, if we are writing a code which essentially means that open port 22, this would apply to all the assets being created out of that infrastructure as code, which essentially means that while we are targeting each service in our earlier stages that we were talking about, it would lead up to only one instance of that vulnerability being open. But with an IAC, be it Terraform, CloudFormation, or any other IAC, it essentially means that if we are kind of leaving a loophole at one point, we are going to leverage it at multiple places, and it will have more than one incident or a scope of incident happening at multiple places in a single account or so. So that is where advanced pen testing attack surface analysis kind of comes into picture, and you can always look at these kind of blind spots and areas which are generally missed. Uh, with that being said, from my perspective, we have kind of covered this whole talk from a pen testing methodology perspective. We talked about the introduction, wherein we talked about the discovery, how we can assess or analyze the attack surface, and then we move to the exploitation pieces, wherein how can we target each and individual service and boil down to very specific use cases that we talked about in terms of compute, identity, and access management, uh, also in other areas like AI and IAC. And with that, all the tools and terminologies that we consume to be able to execute something like that. So, yeah.
Super. Okay, Ankit, thank you so much. A lot of great stuff there. And we've had a lot of questions come in as you are talking. And so we have a few minutes left here. So I'm going to pose a few of these questions to you. The first question is, how can pen testing in an AWS environment adhere to compliance regulations without violating AWS's acceptable use policy?
Sure, sure. Yep. So, yeah, earlier there used to be a declaration that used to be there if we have to kind of perform a pen test in AWS environment, but then it's now no more the case. There is a depicted acceptable use scenario. That being said, I can quote an example wherein, let's say we are performing an pen test considering a HIPAA compliance being met. So we can always get an authorization from the organization we are testing for, and we can define a very thorough scope and define only to include the resources that are handling, let's say, PHI data, and not kind of get into a scenario wherein we are trying to test everything and then reaching out to stages wherein we should not be touching. So maybe like abuse of service by running scans or exploiting or fuzzing the endpoint for AWS itself. So I think we can do it with a very defined scope and very approached manner, and then we can kind of still meet the business objective and also adhere to the acceptable use policy.
Super, thank you. Next question, you kind of touched upon this, but I think it's a little bit more specific. Can you explain the role of the AWS Security Hub and other AWS native security tools in supporting pen testing?
Sure, sure, absolutely. Yep. Yeah. So maybe something like a security hub is an aggregator platform for all the internal security services inside AWS. But then we have dedicated service for each kind of a use case. So something like a guard duty, which acts as a threat detection service. So we can use a lot of intel right from the service, and it can detect a lot of anomalies, like if the API is being triggered from wrong sources, if there is an rate limit being breached, those kind of scenarios get detected through something like guard duty. And then very generic services like CloudTrail, which kind of helps us tap onto which triggering action was done by which entity or resource or individual in the backend. But then also very specific services like Macy or Inspector. So I'll talk about Inspector first. which kind of has the capability to perform a vulnerability scanning and assessment right on EC2 or Lambda and other compute instances, but also on Macy, which kind of is a very de facto tool right in the AWS arsenal, wherein it can tap onto all the sensitive data. We can set up jobs or keep a batch of jobs created to target PCI related or PHI related data. So AWS does have a lot of services that can come into picture, and they all can come together, and we can see a very good visualized view of all the security vulnerabilities using something like a security hub.
Terrific. Thank you, Ankit. And we have time for one more question before we close. And the last question is a good one. What are the limitations of automated pen testing in an AWS environment? And when is manual testing essential to uncover vulnerabilities?
Sure. Okay. So I think while an automated pen testing or leveraging tools is a very essential asset when we are kind of starting with an assessment like AWS pen test, but that being said, manual pen testing is very essential, or is something that cannot be skipped, because it kind of covers very complex vulnerabilities, as I talked about the chaining of attacks, or business logic testing, or providing a very in-depth view into seeing things from a perspective that a human can only see. So that is where I think manual analysis is very critical. Also, something like a complex IAM configuration. So maybe a tool can detect something like if there is a user role that has the admin access and can they do something, but only a human can get into the hindsight of identifying things, wherein they see a Lambda function which has a certain privileges and it is connected to an EC2 instance, and now this EC2 instance can trigger something. So the chaining of attacks is wherein a human mind would only be specialized in understanding and evaluating these kind of attack scenarios.
Super. Thank you, Ankit. And that concludes our webcast for today on pen testing in AWS environments. I'd like to thank all of you who attended, and a big thank you to our guest speaker, Ankit Giri. Ankit, some really valuable stuff, great presentation, so thank you. Please note that this webcast will be made available on demand at breachlock.com after this airing. And if you would like more information about BreachLock and offensive security solutions, please wait for the closing and we will provide more information on how to contact us. Thank you, and thank you again, Ankit.
Thanks, and